Hi there, and welcome to Ian's N-Gauge channel. I'm Ian. In a previous video, I showed how I was going to switch the points on Shelfington using ESU Switch Pilot servo modules. These units could be used with two ESU Switch Pilot extension boxes in order to switch the frog polarity. The extension boxes looked great and would do the job, but were limited in that they only worked with the ESU Switch Pilot servo decoders. I was looking for a more flexible solution that could be used with other servo decoders and would also work when manually switching the points. In truth, I still wasn't sold on the idea that every point needed frog polarity switching. Sure, it would help shorter wheelbase locos get over the points when running slowly, but with locos now having pickups on multiple wheels, even some of the smaller locos should be able to traverse dead frogs quite easily. The other consideration I had was that the current design for Shelfington contained nearly 40 points, so it would be nice to be able to pick and choose where frog polarity switching was required in order to save a bit of money. It was here that Colin from Woodthorpe International kindly offered to send me a Gaugemaster Autofrog unit to test. I wasn't very familiar with this unit, but after a little bit of research decided to take him up on his offer. So in this video, I'm going to show how I tested the unit and decide whether or not if I should use them on Shelfington. The Gaugemaster DCC80 Autofrog is basically a small circuit board that acts as a switch to change the frog polarity when a loco crosses over the frog. It does this by detecting a short circuit between the power being supplied to the wheels of the loco and the power supplied to the frog, and quickly switches the frog polarity to match the wheel polarity. The circuit board couldn't be simpler to wire, containing only 3 wires. 2 were wired to the DCC bus, while the third was connected to the frog wire of the point. The instructions were nice and simple and showed how an electrofrog point could be wired up. To test the Autofrog unit, I decided to put together a simple test track. As I only had access to one Autofrog, the test track consisted of a short straight and a siding accessed via a unifrog point. The unifrog point in question was the one I'd managed to snap the frog wire off while constructing the tricky bit. So after my success with soldering in my last video, I decided to try and fix it. I added a blob of solder to the underside of the frog, and then attached some 22 gauge wire. At the time, I only had red wire in that gauge. The green wire that I used to extend it was 16 gauge and far too thick to solder directly onto the frog. Next, I tested the connection using the continuity mode of my multimeter. I also made sure that the other rails had no connection, as this would cause a short circuit. Once I was confident that the point would work, I used a similar point to mark out where the frog position was on the XPS baseboard. You may remember this baseboard from when I performed testing of Code 55 track last year. Once I marked the frog position, I drilled a hole where the frog wire would go. I could then position the point and pin it down using staples. Next, I added the remaining track pieces and pinned them down too. I then glued some lollipop sticks to the bottom of the XPS foam. These would stop the baseboard from rocking on the frog wire that ran below. Cleaning the track was next. My favourite way of cleaning track was to use WD-40 contact cleaner. I then borrowed some power from the DCC bus using crocodile clips to transfer power across from the rails of my main test track. This then allowed me to use my NCE power cab to control the locos in the test. I needed a baseline for the test, so first I ran some locos without using the Autofrog. I decided to use 3 locos for the test: a Graham Farish Class 03, a Graham Farish Class 08, and a Dapple Class 33. First, I made sure I'd turned off the momentum setting for each loco and ran them at speed step 60 to represent medium speed running. The Class 33 had no problems at all, taking both lanes of the point without any issues. Next up was the Class 08. This occasionally stuttered as it navigated the point, which I was a little surprised about as it handled streamlined Insulfrog points without any issue. The Class 03 was next, and it had a very unsightly stutter as it traversed the frog, but got over it without any intervention. So all of the locos had got over the dead frog when running at medium speed, but what would happen when the speed was reduced to speed step 20? Well, the Class 33 had no problems again, and so could be removed from the test completely. The Class 08 really didn't like going over the dead frog at a crawl, needing help from the hand of God on multiple occasions. Again, this was surprising, as it always successfully navigated the plastic frogs of the streamlined Insulfrog points at quite slow speeds. I didn't hold out much hope for the shorter wheelbase Class 03, and indeed it stopped at first contact with the dead frog while travelling slowly. OK, so these results weren't a complete surprise, but at least they'd been confirmed. Next, it was time to wire in the Autofrog. Colin had already soldered wires to the circuit board, which made life easier for me. So thank you, Colin. So all I had to do was connect 2 wires to the rails and the 3rd wire to the frog wire of the Unifrog point. I did this using a combination of connectors, as I didn't want any permanent connections. I should also mention that because of the way the Unifrog points are wired, there was no need to isolate any of the rails, as was depicted in the Electrofrog example in the instructions. OK, so now that the Autofrog was wired up, we could continue testing. I figured we could dispense with the high-speed tests and jump straight into the crawls. The big test was the Class 03, so I started with that. There was something odd though. While the Class 03 sailed down one lane without a problem, it constantly stalled on the other lane. I tried using different connectors, cleaned the track again, and eventually used my multimeter to check for continuity and voltage at the frog. The problem seemed to be that the relay wasn't switching as expected. The frog was powered for the bottom lane, but wasn't switching for the top lane. After a bit of head scratching, I wondered if it was something to do with the current required to throw the Autofrog relay. The power supply supplied with the NCE power cab was a bit underpowered in my opinion, supplying only 1.8 amps, and I wondered whether it was capable of providing enough current to throw the Autofrog relay. It was just a hunch, but I switched controllers to my newly refurbished Yamaha YD7001 and started the test again. Once I'd switched controllers, I set the Class 03 running at about speed step 10, and watched in awe as the little loco successfully traversed the point. But would switching lanes work? Yes, you could hear the relay click as the loco initially encountered the frog. Awesome. The Class 08 was next, and this also traversed the point. Again, you can hear the Autofrog relay click when switching from one lane to the other. I did another run with sound enabled on the Class 08 just to see if there'd be any audible difference as the loco went over the frog. As you can hear, there wasn't. What a brilliant bit of kit. Okay, so that's about it for this update. I have to say a big thank you to Colin for sending me the Autofrog so I could test it out. I think I'm sold on them. They're fairly inexpensive, extremely easy to wire up, work whether you're manually switching or motorising the point, and can be added to the point after it's been installed. I don't really see a downside, other than I'll have to upgrade my power cab's power supply if I want to use it to trigger them. As usual, let me know what you think. Have you used these Autofrog units or something similar? Let me know what your experiences are, whether good or bad. Alternatively, if you've got any hints, tips, useful tools or techniques to pass on to a beginner in N-Gauge modelling, or if you simply want to say hello, then please do so in the comment section. Anything and everything you've got to say will be greatly appreciated. In the meantime, thanks ever so much for watching. Hopefully I'll have another update on my progress soon. Bye.